we're releasing today is a new tool, product, and I want to help people learn about it. So the problem that we face in Android development, who in here is an Android developer? You actively build Android projects. We have a few of you, okay? Who has ever, in your Android app, have had to store things in a SQLite database? Should be like the same subset of people. It's a common thing that almost every application has to do. But the problem is we found, at least I found, that the Android SDK just doesn't provide a lot of help. You get SQLite Open Helper and some SQLite libraries, and Google says, go have fun, create your own data abstraction layer, and save stuff and do all sorts of nasty manual SQL queries. And there's a lot of solutions out there. The documentation doesn't provide a lot of guidance either. They kind of say, here's some general practices. This is what you do need to have happen to make sure that you can save stuff to a SQLite database. And because there's not a lot of direction, the SDK is not providing a lot of help, there's a plethora of different kinds of storage options and technologies that you can use to get this work done. And we weren't super happy with any one of them. There's a lot of ones that are really good that we've used before. And so we set out to solve this problem, and we're going to talk about what we came up with. One of the core components of the Android SDK, excuse me, is a class called a content provider. Now, of those Android developers, have you heard of a content provider before? Let's get a couple of little nods. Okay, content provider, you use them. They're in the system. It's a core part of the system because the nature of an Android application, for those of you that aren't really familiar with it, Android is designed to be a completely user-centric system in that the user gets to decide which applications are preferred for certain tasks. And the screens that you have, which are activities, get tied together via a system of intents. So your application has 10 screens in it. Okay, they're all like activities. They could be composed of other kind of sub activities called fragments. But to navigate from screen activity to activity, you send intents. And basically that's just saying, hey Android, I want to go do this other task, and will you resolve and find an activity that would accomplish this particular task? And you can pass it in some arguments. Most of the time we found that we just explicitly say, hey, we want to do this particular activity. It's in our application. We don't want to send you somewhere else. But a lot of times if you're going to go take a photo or do something like that, you're just going to say, hey system, I want you to take a photo. And Android will allow the user to install multiple different, competing different types of applications that do the same kind of task. And if there's more than one, the user gets to decide which application handles the intent. And so this is kind of, I gave you this backstory because, and this doesn't have to do with data persistence, but everything in Android is designed to take the user between processes, between application to application, in a seamless manner. Where if I want to take a photo, or I want to pick a contact, or I want to do SMS, I can make it a seamless process to send my user to another application, an activity in another application, as easy as it is, as seamless as it is to have that activity in my own application. And so because of all that transfer, and we kind of want all the applications live on the same level, they have this idea where we're going to share data between processes. And the contacts application on your Android system will expose contacts data via a content provider. So it provides kind of a REST-like interface, an API for accessing that data. And that's all accessed through a content URI. And here's kind of an example of a content URI here. It's just made up. And it's a content : // Usually it's an authority ID, which is generally the kind of package name, with maybe it can be custom though, /table, and then it could be drilled down even farther, like in a specific ID for like a particular record on a table, or just a set of arguments. And you're able to take certain verbs, just like making a web request. You could query, you could insert, update, delete. There's kind of an analogy there with web APIs. So so my application, I can write a content provider and expose it, and other applications can be able to, that I get good access to, can read that information and make it part of theirs. And it's all kind of part of the whole Android idea where information can be open and it's shareable, and there's APIs to facilitate moving between applications and sharing content. And so that's kind of the backstory of content provider. We looked at content providers, and while the API and the intent of the architecture behind them is designed specifically for the task of sharing information between activities, between applications, we like the architecture for our own data too. Just making content providers that were for our own data, because we found, in actually a lot of cases, our applications would have multiple processes, such as in iFit. We have to have an application that runs 24/7 inside of a gym, and it can't go down because it's going to kill somebody if it malfunctions. And so we have multiple processes, and content providers really help facilitate moving data between processes, and we like them, but there's some problems with them. And we'll kind of get into how the API works, but this is kind of an example call down here where you can use the content resolver, which is accessed from an Android context, and you can do a query, you can do an insert or update or a delete, and you pass it these content URIs and along with some query parameters, and you can make these operations on your content provider without having to have a reference to that class. Android resolves it for you. Okay, so just to recap some of the benefits, Expose is a nice REST-ish type API for your data. It works across processes. It allows you to share applications information between applications. However, all these nice things, the reasons why we like to use content providers, they are really hard to write correctly. Has anybody ever written a content provider before? Okay, you have one. So they're not very commonly written. Because was it hard to write?
Yeah.
It took a couple weeks. And yeah, just to understand it. And then did you ever have to make a change to it? And then it takes a couple weeks to figure out, like, all right, I got to do this one thing, and it's just like a lot of code to write to do something that should be just really simple. And simple by I mean, I do iOS development too, and this is what we use for iOS data persistence. We use core data. And so we come in here, and this is just a boilerplate starter app that I just barely started. And I can come in here and add a new entity, and I can rename it to be like my agenda, and I can go and add new attributes. I can look at it as in a visual model, and I can relate attributes between these entities, and then I can go push a button, and it generates all of my managed objects, and then I can use those in my code, and any time I need to make a change, it handles versioning. It does everything. This is just a really nice out-of-the-box solution, handles multitask, multi-threaded stuff, and it's just really cool. We love core data. It is also difficult to understand sometimes, but there's no tool like this in Android. We wanted to fix that. So they're hard to maintain, they're not commonly used, and so they're not commonly understood. And because they're not understood, it's hard to get to your dev team. You're hiring new people, you're trying to field this team. It's hard to get them to do it right. And so the common solution, just don't use them. Use something else. Use some sort of an ORM, object relational mapper, or just write your SQL stuff yourself, just kind of ad hoc for your application. But our solution is to get a RoboCoP. Now, RoboCoP is our new tool. It's a cool name, I know. So it's a code generation tool for automating the creation of content providers and other helpful classes that help you work with that content provider. So the way that name came about, we looked at androids, droid, so the robot, and short for robo, and content providers, CP, or its initials, and if you leave the O in there, we get a cool name, RoboCoP. Should be easy to remember. Remember RoboCoP. Okay, it's open source. It's built by Rain. Rain was kind enough. This has been an internal tool for a while. It started its days as a Node application. Actually, we use Node and Jade templates to generate Java classes, and then we copy and paste them into our projects. And so we looked at that. We said that's not a great solution. We want other people to get on board with that, but we didn't want Android developers having to go install Node, be able to find our package using npm to install it and spinning up a server, and it's just not part of our discipline. So we rewrote it in Java, and we've open sourced it. Today, you guys are among the first to hear about it. It has Apache license, so you can use it in free and commercial products, and it's available on GitHub, on MediaRain's GitHub account, RoboCoP. It works as a Gradle build task, so right now you will need to use Android Studio, but you should be reasonably able to make it run just from command line without Gradle. Should be fine. And it's easy to set up and use, and we're going to kind of walk you through how that is supposed to work. So here we do a live demonstration. Please be kind and patient as I kind of fumble through this a little bit. The past few weeks I've been working more on getting the tool ready and available for you guys to use right now than I have on this demonstration. So the code example that I have is a little bit contrived, and I think what we'll do is kind of go through a little bit of coding an example application. How do you write a schema? How do you generate the code? How do you use the generated code? And then I want to take you into the internals of RoboCoP and kind of give you an idea of how we built it and some of the technologies behind it and how you can get involved and extend this so we can add new functionality. Because this is an open source project. The intention is that, you know, we've only built RoboCops based on the needs that we've had for our applications. But what about your applications? You know, we want to see, you know, the use cases that it doesn't cover and allow you to have a platform to add to. We want to build a really great tool here. Okay. So let's switch over to some live coding. Let's quit Xcode. We don't need that anymore. Okay. And here we are in Android Studio. So I've got a kind of a sample application. The application is I call it an agenda builder application. The idea, and I didn't finish it, it's kind of some preliminary code here, is that you'll be able to go and create like agendas for like meetings. So you have like a name of the meeting and who's conducting, and you have like a calendar of items that you could add something, and you could distribute that to people at your meeting, and then it would carry over from, you know, from meeting to meeting, and like calendar items that haven't yet elapsed, it would kind of remember them. It doesn't do anything near close to that right now, but there is enough framework in here for us to see most of what we need to, how we need to use RoboCoP. All right, so RoboCoP is a few things. Okay, so let's go to the GitHub repo real quick for RoboCoP and kind of show you what's going on. So this is the library. All of our source in here. It's actually not very big. We're using Apache Velocity engine. It's usually a Java web technology that, you know, renders pages, and we used it to render Java files. It's got a really nice templating engine, and it's all Java, so we can package it into a jar and we can include it as a dependency. So to get this, you go to RoboCop's GitHub page, you go to our releases section, and you'll find our first release. We're calling it 0.5 because, you know, we think there's probably a lot more use cases we need to be covering until we can really call it a version 1. But it works for us right now. So you go down here, you download the jar, and you can download the jar with the dependencies, which will come with like JSON and Apache Velocity and other things that the tool depends on, or you can download just the regular jar and satisfy those dependencies yourself in another way. I downloaded the one with dependencies for this project, and I come in here to my Android application, and I created a folder called RoboCoP. Sorry that that's not bigger. I don't know how to increase the font size for the menus, but there's a folder there. If you can't see it, it's called RoboCoP. And I dropped my jar in here. Okay. The next thing that I want to do is go and define my schema for my database. Okay. So this is pretty simple. It's just a JSON file. You just call it whatever you want .json, and there's instructions on that GitHub README exactly how this is formatted and what it's expecting you to write here. But I'll go over it right now. The package name is kind of just the base package name for your content provider. So this application is com.rain.android.agenda, and then I tacked on data for my content provider. And that's the directory in which all these sources will be generated, and you'll see that in a minute. The name of this provider is agenda. And now we have a convention here is that all of our strings, all our values that we're putting here in the JSON objects are lowercase and underscore separated. Okay? Excuse me. You can do whatever you want there, but the code is going to look a lot nicer. It's going to be, you know, standard Java, camel case, and, you know, everything. If you write all just lowercase and underscore separated values. Our database version, we're at version 1 right now, but as you upgrade and you change, you can increment that up, and it'll actually insert that into the generated database file. And you've also got, here is a collection of tables. Okay, so the tables are pretty simple. You've got the name of the table, and then a collection of members. And each member object has a type and a name. Okay, and the types that you have here, you've got all of it. These are your, we want you to put the Java types. Okay, lowercase. You can do a string, you can do a double, you can do a float, you can do an int, you can do a boolean. And those will map to proper SQLite data types, but we're going to generate some nice helper model classes, and we're going to get our Java types informed from this. Okay, so our agenda items have name, a date, and the person conducting all strings. Our calendar item table, we've got a title, we've got a date, time, location, and some notes. Okay, agenda item group. So this is the kind of groupings of little agenda items. The groups are just the title and description. And then the items themselves that go into the groups have title and comment. Now, this iteration of the tool has support for relationships. Right now, it's just one-to-many relationships is all we're supporting. Our plan is, many-to-many is on the roadmap, but it's a little more complicated, and we wanted to make sure we got this right. To be honest, we've never really had a need for many-to-many in our applications. Like there's always a more convenient way to do it. I think what my theory is about it is the nature of mobile UIs predicates that you're really only showing really discrete pieces of information. You know, you'll present your users a list of like per people, let's say, and you click on a person, it'll show their contact info. And as you move from activity to activity, you're making new queries, you're passing around IDs of other records, and so there's really not a lot of cases where you have to do these like complex joins on mobile. So one-to-many is what we got so far. And this is how you do it. You can name the relationship, and you provide the left side of the join, the right side of the join, so you've got your agenda and your calendar item, so that there should be one agenda for one or many calendar items. And you specify the type to many, which is the only valid type right now. And we have the same kind of thing for these agenda groups and for these agenda items. Okay. Before we move forward, I want to see if everyone kind of tracks where we are and understanding this model definition file. Does anybody have any questions so far? And if I can't see your hand, just speak up. Okay. All right, we'll go forward. Hopefully it's pretty understandable. So, all right, so the next thing we got to do is go and set up our build.gradle file. Okay, I have already got this set up. There are a few things that you have to keep in mind. So the build.gradle file, one thing you need to remember is that we're going to be editing the main application module build.gradle file, not the top-level build.gradle file. Okay. I guess there's only a few Android developers in here. Who's using Android Studio and Gradle to build their applications? 1, 2, 3, 4. Okay, cool. I highly recommend it. I wouldn't have recommended it about 6 months ago. It was just not stable. But it's getting pretty good now. I think it's time to move over. If you're using something like Maven, a lot of these things should work out. But some of this might be a little hard to understand. But you should get in with this. So if you're using Android Studio, this applies. Otherwise, you need to figure out how to run this from command line. Okay, so we had this build script item here. You might recognize this from the top level build script. The build.gradle has one of these. We're going to add one here, and make sure it has your Maven Central repositories. We actually probably don't need that for this at this point. I do want to publish this to Maven so that we can pull it in without having to reference the jar, but that's currently not there. And then you have to include in the class path for your build script the RoboCoP jar file. So it's relative to this module, RoboCoP/RoboCoP 0.5 jar with dependencies.jar. Okay, once that's there, and make sure you don't include it with your regular runtime dependencies. RoboCoP is not a runtime tool. It's just for when you're building your code. So we're going to import the generator for RoboCoP up here, with this import statement. This allows us to call methods on classes in our jar from a custom Gradle build task. Okay, and that's this right here. This task content provider gen. You can really call this whatever you want, but I feel like that worked for me. And inside this do last block, we have a couple of parameters that you need to add. So one is the schema file name. So you've got RoboCoP/agendaschema.json, which we just saw. It's in RoboCoP, and we also have the output, the base output directory. Now this base output directory can be can really be anything. Some of our users have wanted to put it into their main source directory so that all of the packages were in the same place. I like to put it into an external source gen package or source folder, and that way you kind of keep generated code out of the way of our own code. Okay, because this gets regenerated all the time, and we just don't want that cluttering up our main source folder. And you can also just kind of ignore this in version control and just require that everybody run this build task before they build. That way you can keep your this stuff that we don't edit out of our version control. If you're going to do an external source folder like I have, you'll also need inside of your Android code block is a source set item. The source set item will allow you to add new source folders to your application so that the Android build tools will build your content provider with everything. Okay. All right. So now you've got your Gradle build file set up. You've got your agenda schema defined. The last step to get this started is to simply go and generate the code. Okay. The easiest way to do that is to identify your build task in your Gradle file. I just selected that with my cursor, and I do a right click, and I go run Gradle content provider. And it'll run this build task. And it'll generate these sources, and we're successful. We've got it. Okay. And inside of these sources now, I've got a whole bunch of code that was generated from that one JSON file. And I'll kind of give you a browse of what this code looks like. All right. So we have the agenda provider. This is the actual content provider class implementation. So content provider, like we said, is an abstract class. It doesn't give you a whole lot. It gives you like a query, insert, update, delete. You have to implement those methods, and then that's it. But to actually build a good content provider, it takes a lot of code. Okay. This is why we want to generate these. And you're smiling over here because you remember writing this, right? And so we don't write this anymore. Okay. Don't write these. We don't recommend it. Use RoboCoP. So kind of how this works, and we talked about how content providers work with these content URIs. So we generate this authority based on the package name that you gave us, .provider, and then we create the authority URI with content URI : / authority. And then we have these content URIs for each individual table that you defined in your JSON. So we've got your agenda, we've got your calendar, we've got your calendar item group, we've got your agenda items themselves. And you've also got the join relationships that we defined down there too. Each of the join relationships get their own content URI path. So you can query that particular join, and it'll know to join those tables before it satisfies those queries. Okay. Now you've got these URI matchers, and all of this is necessary boilerplate so that when you get the URIs in, when the content resolver, when an application tells content resolver, I want to query contents for this particular table at this content URI, it passes us these URIs, and we use this content URI matcher to identify which table that we're talking about. And so it's going to go and try to match which tables it goes to, so that when we get it into our query function, we know how to deal with it. And like I said, you don't have to worry about any of this. It just works. But I do want you to appreciate how much code is being generated here, because I think it's pretty cool. We worked hard on it. And so it's one of the things that this is going to do also is when you query, it's going to set up these observables, these notification URIs on the cursor. So, and we're going to show you how this works, but if you use this cursor and use like a cursor loader to populate a list view in Android, that list now is going to observe and match the data on the table, on all the changes that happen to the table. So I can be in this background process synchronizing records with the network, and I'm just observing this local content. And as my background service is inserting stuff, my table starts just going crazy and just adding new fields and everything. So this kind of takes away some of the communication hassle of notifying when records change and things. You could do this before in other ways, and other tools do, but this is kind of like the standard content provider way of making this happen. Okay, we have inserts that update those URIs, updates and deletes. And this is our content provider. Okay, just appreciate that you'll never have to write one of these again. And so one of the nice things about the tool is that it generates these nice classes for you. So we've got interfaces that define all of the columns in your tables. We've got for each table gets their own unique identifier, this ID, and the title, comment, and if the table participates in a join and it's the many side of the join, you'll get your foreign keys. So for instance, we've got our calendar item table, we've got our agenda ID. So we can find our calendar items that match a particular agenda. And you've got all your creation and insert and drop statements, and we've even got some really nice helper ones like where ID equals. So if we in a query, this is something that you write all the time. ID, some field plus quote equals question mark, and it'll escape, the variable for you. And if that table participates in a join as well, you'll get the where the foreign key equals something else too. So it helps you write your code a little better. So then in our model files are also pretty nice. You can inflate a model, one of these classes, from a cursor. So let's say that you went to Content Resolver, you did a query, and you got your cursor back, and as you're iterating over those, you really don't want to just keep on accessing your fields by int index. That's probably the most efficient way to do it. It reduces memory. You don't have to create new objects and stuff like that. But sometimes it's just easier and better to work with the real Java object. So you can pass your cursor into the constructor here, and it'll inflate all these values for you. And you can modify that object, and when you're done with it and you want to persist it back into the database, you can ask it for its content values. So every time you make a change to this object, we're changing these content values object, the class that it has on with it, and you can use that when you're inserting it back into your database via the content resolver. So that's really nice as well. And we've got our actual database implementation, which allows us to, it creates our new database for us. It inserts our version. It creates our tables for us. When it upgrades, it'll drop your old tables. It'll add your new ones. One thing that we don't have yet is any sort of facility for your upgrade logic. Okay, so this is getting rewritten every time, and so we're still kind of working on a best practice strategy for migrating your data from one version to the next. And that should be coming soon. Okay, so now that you've generated these files, the last thing that you need to do is to take this file here. So we generated an extra XML file, the content provider XML. This is the string, the node that needs to get put into your Android manifest. So you come in here to your source, Android manifest, and you make sure that your content provider is stuck here inside the application node. A couple of things in here. So we've got the name of our content provider, which actually just identifies the class which the content provider is. And you've also need to specify the authority that the content provider specifies, so that when any other application, but in this case just our application, wants from the content resolver a content provider at this authority, it finds the provider from this manifest file and directs it to that class. Hopefully it's not too complex, but this is how Android finds your content provider. And this exported property we set to false initially. This should only be set to true if you know exactly what you're doing, because your application data will then be visible to other applications in Android, and you may not want that. But we use content providers because you can do that, and we think that's great. So set it to true if you know what you're doing. Along those lines, another thing that the tool doesn't yet do is provide any sort of access control. Like if you've used the Contacts API content provider in Android, there are certain things you can and can't do with that content provider as an external application, and we don't have a facility for that yet. So something that we're looking at. Okay, so our provider is installed, our code is generated. Now we can get into the business of actually using our content provider to do stuff with our application. So what I did here is I created the application using the content provider, and then I simply just went and removed the lines of code that used the content provider and made some to-dos so that I can kind of walk you through how this works. I don't make a lot of promises that the application will actually run after this is all done, because it's live coding, and we don't have a whole lot of time to make sure it's perfect. But so we'll tackle these one at a time. We're going to go through our fragments and make sure that we're requesting the right data. So agenda list fragment. This fragment is going to list for us all the agendas in our database. Okay, so it is a list fragment, and it's implementing the loader callbacks. Who's used loaders before? Cursor loaders in general, a little bit. They're new. They're as of Honeycomb, really, but they're supported in the support library. Okay, one of the reasons why I think people don't often use loaders is because, like many other Android components, they're built to use content providers, and content providers are inherently hard to write. People don't write them, so they don't use loaders also. So use loaders, they're awesome, and use a content provider because it makes it easy. Okay. So what we're going to do here is in our list fragment, we're going to go and fix our adapter. Our adapter is set up. It's a simple cursor adapter, which is going to be able to take our data, and it's going to map a cursor row to some sort of a UI view. Okay. So we're using the Android simple list item 1, which is just a regular list item with one piece of text, and we're going to be putting a field from our agenda table into the text1 field of their list item. So we'll come in here and say a new string array, because all of our table fields are strings, okay? And we're going to access the agenda table dot name, okay? So that's our name for our agenda table. It's going to be put into this this text field 1, okay? And then so we're going to get rid of that to do. That's done. And now here, so cursors are cool. Some background on cursors. Cursors, in order to use a cursor or a cursor loader, loaders in general, you have to implement the loader callbacks. And our loader callbacks are type cursor. So we're going to create a cursor loader. The loaders accept a content URI, and they are automatically listening to the life cycle of your application. So as you rotate the device and the activity is being torn down and recreated, or you're leaving your application, you're doing other things, the loader is going to be making sure that no matter what happens with your application state, it's going to fetch the latest stuff, and it's going to observe changes on that content. Okay, and so you used to have to do like requery and it's like activity.start managing cursor and all this other nasty stuff. You don't have to do that anymore with loaders. You just let the loader take care of it. So to do that, we're going to create a new cursor loader. And we're going to new cursor loader. The loader is going to take a context, which we're in a fragment, so we'll go grab our activity, because that's a context, and we'll get our URI. So we'll go in here to the agenda provider dot agenda content URI. That's our agenda table. All right, and then we're going to pull in our projection. This is the columns that we want to come back. It's not efficient to put a null here, but for speed, I'm just going to say, hey, return me back all the columns because I need them. In a selection, since we're listing all of our agendas, we don't need a selection. This is your query parameters, and in the selection arguments are, with those query parameters, what are the escaped values inside. We will use the query parameters in just a minute, but not here. So null and null for the order because we want natural order, and then we're going to return this loader. And when the loader finishes, it swaps the data with the active adapter, and when it resets, it clears out the data by passing in a null, and it just this code right here for these callbacks manage all of your listing of your data. That's all you have to do. And then we have an auto event. Square has a great class or library called auto, which we send messages back, which isn't part of this. I've got an error here. What's going on? Okay. It's not using the correct version of cursor loader. We want the support library cursor loader. So, okay. All right, so that's kind of how you would do a general query using a loader with a content provider. What time is it getting to be? Okay, it's 3:21. We're good. Okay. Let's get rid of that to do. Okay, let's go into the edit agenda fragment. So we're listing these agendas, and when we click on one, we're going to go and I wonder if this runs. I don't even know. I started deleting code. I don't know if I blasted something that we need. I've got an emulator running. I thought the coding might be more helpful and interesting than the actual application, but I want to make sure we're doing it right. As long as it doesn't take a fortnight to get this thing going. Good. There we are. Now there's our list. I can go and add a new item to the list, and it goes and creates a new one and then pops another activity, which I haven't completed yet. But I think there's some click issues going on here. Yeah, it's not registering my clicks correctly. It's an Android emulator. Anyway, so that's cool. It works. Lists. Okay. So back here to to-do. This is a form. I'll kind of show you what the UI looks like here. And this will be a practice of retrieving a single record and inflating one of our model objects that I told you about. Okay. So we're going to go and get the agenda record from storage using the agenda ID we were given. Okay. So let's get a new cursor, agenda cursor, and I'm going to get, let's see, got to get the activity, because that's the context that we use, and that get content resolver, and then query, and then we use our agenda provider dot agenda content URI. That's our agenda table. We want all the fields again, because we are just displaying everything inside of a form so that we can edit that item. But our projection, our selection, we're actually going to do something here. So let's go back to our agenda table dot where ID equals, okay, and we're going to do a new string array so that we can add in our agenda ID, which we were given. We were given it from this static creator, and it's going to be the agenda ID. ToString, it's a long, and then null for the sort order, because it's just going to be one record, okay. And then for cursors, you have to remember to move them to the first, and this can actually throw an error, but it's not in our case. So in real production code, you'd want to capture that exception somehow. And so that moves to first, and then we're going to create a new agenda object, and we're going to hand it that agenda cursor, okay? And that's going to inflate our agenda object, and then I think we're good. We're going to actually get this to a field, and so we can reference it later. Okay, so that's when it creates. We're going to go and capture the record that we were given and make it into an object so that we can manipulate it. Okay. Down here, when our view gets created and we have that object, we're going to want to initialize our UI with that object. And kind of show you how you can use the objects that are the classes that are generated by RoboCoP into your UI. So in here, we've got a couple of edit texts we're going to want to populate here. These are done via Butterknife, which is a really cool library from Jake Wharton. He's got a lot of really nice stuff out there. Some syntactic sugar for not having to call, find view by ID all the time on stuff. I highly recommend it. But in this case, we're going to want the, let's see, the agenda title and then person conducting. Set text, and we're going to do the agenda dot get name, okay, and person conducting set text get person conducting, okay, and there's our view initialization. That should get everything in there, and then when we're done editing this field, we return back and our application is pausing, whatever, we're going to want to persist those values to the database, which we're not going to do from here. We're going to do in the activity. We're going to send an event. But we're going to update this object, okay? So we're going to say the mAgenda title dot set name. Let's see, that's not what we want. The mAgenda itself dot set name. We want the agenda title dot get text to string, okay? And the agenda dot set person conducting get text dot to string. I'm feeling like there might be another tool in the works for mapping fields to edit text to database fields and have that like bound or something. That'd be cool. Anyway, so then once that is done, we're going to do this to do. We're going to pass that object back in an event so that our activity can handle that and persist it to the database when it needs to. So we're going to say private agenda, and we're going to create a constructor parameter from that. Refactor. I'm going to get a getter for it, and then back up here, agenda. Okay. All right. So now our form for editing this particular agenda item should be able to get an ID. It's going to inflate an object, and it's going to use that object to set some text and some edit text, and then automatically persist that back into the object and send it back to our activity. So with that, we're going to need to go and edit the activity which actually does the persisting and updating. So we're going to do edit agenda activity, this to do. So we're going to get this event back. This is via Square. They make some great open source products. This one's called Auto. It's an event bus framework that I use all the time. I really like it. I'm going to press those. Okay, so we're going to get the agenda off this event. Get agenda. Okay, we got our agenda. Now we're going to persist this back into our database via the content resolver. Okay, so we're going to get content resolver dot update, the URI being the agenda provider dot agenda content URI, and then the content values. Right, great thing. Our agenda object has get content values, so it'll actually give us a nice content values object with all of our values. And then the string where, we're going to have a agenda table dot where ID equals, and then our new string array for the values, and we'll get the agenda dot get row ID dot to string. Okay, and that takes care of that to do. Now these that should be persisted to our database now. So let's go and run this, and hopefully the click events are working on my emulator a little bit better. See what happens. Okay. Okay, so we have our agenda items. Just clicking on one. There's our new agenda. You see it's there. It's really annoying because I click, let's see if I click, there we go. It's just off by a couple of inches. And modified. Okay, and our person conducting is me. And we're just going to go back, okay? And it's modified. It's in the database. It's already updated. This cursor loader picked it up because it's using a content provider. It automatically gets that update, and we've got it in our table. So that's kind of a round trip. Now, I'm not going to kind of beat a dead horse here because all the other fields, other fragments and activities that I would go and finish all these to do with really have the same kind of pattern. We're using the content resolver, we're accessing those content URIs, we're using the constants, we're using the objects, we're inflating those from cursors, and we're getting those working in such a way that we can make data persistence and stuff on our database and everything really easy inside of Android. So what I want to do for the last 15 minutes is to shift gears and show you guys how we built RoboCoP and get you guys involved in some way. But before we do that, does anybody have any questions on usage patterns? Yes?
So for writing custom queries, write the write clauses, would you just like write that directly in the query when you make that query, or would you put that and put it in the object because it will get regenerated?
Right. Hold on a sec. Let me pull up something that might help. So let's the edit agenda item fragment. That's not what it was. Edit agenda fragment. Okay. So that you're talking about when we make queries to find particular records and stuff.
Yeah.
And
other than just where ID equals.
right.
Say like where ID equals this and something greater than whatever.
Yeah. So in this case, we would do agenda table dot name. And we do it like that, and then you pass in whatever values that you wanted to. So you can access those, but you just kind of have to go through the ceremony of doing the concatenation with the escaped. With these question marks, you can add as many as you want, and then this string array would match up to all those escaped question marks for your query. Does that answer your question?
Yeah.
Yeah, so these are just convenient ones that we use most often, and we decided to just put it in the generator, but other ones you have to write like this. Yeah.
I was just wondering if there was a place to store it besides just write where you have to put it.
Yeah, that's a really good idea. I mean, I guess one of the limitations of Java, we don't have, like in C# you've got like the notion of like a partial classes,
Yeah.
which are great for generated code because you can add them. Objective-C has the same kind of thing too. But yeah, no dice for Java. We're looking at like, there might be some room for this kind of a thing with how we're going to approach the data migrations in the database class. You know, we're going to have we thought about maybe having reserve tags so that before we regenerate, we like go and capture some code from your current class and then copy it back over. But what we really want to do is have some sort of dependency injection system so that you can write your own classes and you can have like a dependency injector that will actually provide the instance of your data migration toolkit or something like that. And you might be able to do something like that as a way poor man's partial classes or something like that. So, okay, any other questions before we look at how RoboCoP is built? Cool. All right, so over here, I've got the RoboCoP project. Hey, Jeff Potter, you're here, aren't you? I don't need to talk to you anymore. Okay. All right. So I've got over here these. This is inside of this job. This source folder here is all the stuff that makes RoboCoP work. It's really enabled by Apache Velocity. It's just an outstanding library. Really glad we found it. And I'll kind of show you how those work. So inside of resources, we've got these .vm, the velocity models. And these are all of the classes base template classes that get generated with the tool. So here's our content provider. So I need to make this a little bit bigger for you guys. So one thing we liked about Velocity is that is the syntax. We were using Jade in the Node land. If you guys have used Jade before, where it's Jade's like default is that everything is code except for where it's like pipe commented. You have to have a pipe at the beginning of the line, and then you can have like plain text and inject variables and stuff in there as you go. Velocity was the exact opposite. Everything is regular text. It just gets printed as is, and you can inject variables into it like this. So what we did here is we have this content provider writer, and this guy sets up these velocity context objects. Okay, this velocity context is just like a map with it has names and values, and you pass these velocity contexts into your templates so that you can access these named values from your template scripts. And so we come in here and our content provider generator is actually what gets called by your Gradle build task. It passes in your schema path and the output source path. It creates a new writer and it passes those items in here. So we're going to create this content provider and it's going to go and create a new JSON. We're going to get that object from your content provider model. So this is this class here, which is, sorry, my workspace is kind of custom. this guy represents is the JSON, is the Java equivalent of that schema file that you wrote. It has all these serialized names for package name, provider name, etc. So let's say that you want to extend RoboCop. You need an extra thing, an extra class, whatever, and you want to put that stuff into your schema and have that accessible inside of these templates. You would come in here to content provider model. You would come down here and add an extra variable. Make sure you kind of match up, what your serialized name wants to be. And now, when this comes over here and we create that model in our content provider writer, we can then use that inside of our Java code and inject that into a velocity context, and then allow that to inform, give content into our templates. Does that kind of make sense? So from the JSON, it's parsed from JSON into a Java object, which is this velocity, this content provider model, which gets created by this content provider writer, which then gets packaged into a velocity context, which is then accessible from a velocity model template. So there's kind of quite a few steps. But once you kind of get the workflow down, it's pretty easy. So inside of velocity, you've got a number of control systems. You've got for eaches. You've got ability to create new variables and set their values. You can access those variables and increment them and change them in different ways. And so you can have all sorts of programming logic and control flow control. And you can generate all sorts of things. Okay. This is how you reference variables with this dollar curly bracket. And when you set variables, it looks like this, and you create a new variable with just a dollar sign. You can concatenate things, normally just by writing a regular line and then just having a variable and then put it next to text, and that's it. So pretty cool. So the different models you've got your database model. So if you wanted to come in here and help with our data migration strategy, you probably want to come in here and edit our velocity, our database.vm. And on upgrade, you want to add some sort of facility there. And so all these are backed by actual Java objects that we can use, and as a test bed, so that you can kind of monkey with this without having to get an actual Android project spun up. We've got this client test application, this little module inside of the project with a main class, and basically see a bunch of commented code where you see how this works. Is we just, instead of parsing our JSON directly, we just kind of created our objects the way that we wanted them and passed it into our content provider writer. So we commented that out because when we got the JSON parsing working, but you can still go back for kind of just testing and ad hoc type of tasks to get this working the way that you want. So I recommend you go to the RoboCop repo, you pull it down, walk through it, make sure you understand it. When you use code inside your project, especially when it's generated code that it's going to be shipped with your binary, you want to make sure you know what it is, the consequences. It is Apache license, it's shipped as is, we provide no warranties, so it's your responsibility to make sure that it works for you. And so in conclusion, kind of just go back to my slides if I can. Nope. This code is posted on my GitHub. My GitHub is Dustin-Graham. That's my name. Also my GitHub handle. And you can find that repo, and you can find the example project with the agenda helper, and also find RoboCop, which is on MediaRain's GitHub, called RoboCop. You just do a GitHub search for RoboCop, and you will find it. So I'm around for questions. There's a couple minutes left, but that's it. Thanks, guys.